So this is your lecture number 5. We are continuing with add, delete the node at a particular position. So when you are asked to do something with the linked list, which is not at the beginning, not at the end, somewhere in between, you will be either provided a position for that node. So let's say I ask you to delete the node at position number 2. If you see, I've mentioned the positions here. So I have to delete this node. Or you may be asked, delete node 10 from your linked list. So you have to search for the node, okay? And you have to see whether the node is in the beginning or it is in the end or it is in the middle, and accordingly you have to delete, okay? So for example, I asked you to delete 10. That means in this current scenario, 10 is a intermediate node, so you'll have to apply add delete at the intermediate position. But suppose 10 was the first node, so deletion of 10 in that case would mean that you have to delete a node at the beginning. So you will have to take care that your start pointer is to be updated and do what we did for add at the beginning. If your node 10 was the last node, then you'll have to add delete accordingly at the end based on what we did before. So how do you know the node is at the beginning or at the end? You always have the start pointer, so you'll always find out. It will be like a special case. If your start to element itself is the element that you have to delete, means you are going to delete the start pointer, the starting node. So start pointer is going to be updated. So you will follow delete at the beginning, okay? And if the next field of your node, for example 10, is null, that means this is your last node. So these are to be taken up as separate cases when we program. Okay, for now, let's say whatever we are given is always present somewhere in between. So we will see when we find out that our node or our position is an intermediate position, how do we go about deleting it. So we're doing addition first and then we'll do deletion. So let's do addition first. In this case, I want to add my new node 50. Initially this next field is null. I've just put 3000 here, which is the updated value. So we just have this node 50 which has address 4000, and we want to add it at position 3. Okay, so to add it at position 3, because when we add it after 10, it becomes 1, 2, 3, and this one becomes 4. These are the initial positions. Okay, so what do you mean by adding this node? Now this node is going to be next in sequence. So 5, 10, 50, and 15. So that means 10 should point to 50 and 50 should point to 15. And when we change these pointers, this one is automatically overwritten, because now you, instead of 3000, this will have 4000 later on once we do the addition, and this will have 3000, and this is kind of discarded on its own. So again, the question, when we add this, should we do A or B first? So as I mentioned last time, if you do A first, you will lose the address 3000. So we will do B first. So how to get to 10 and 3000? So to add something after, okay, to add something after 10 or at position 3, you have to be at position 2 to add something to position 3. Okay, so how do you go here? So till now we know how to traverse the end of the loop. We can use temp is not equal to null, temp to next is not equal to null, and get this address. We also learned that we can also get this and this address together, but this time the condition is different. We need to have position into consideration. So to add after 10, you need to be at 10, because the pointer that you're going to update is for 10 as in A, and then we'll see how we'll do the rest later on. So we loop till the particular element 10 or position 2, whatever is given to you in the question. So if I ask you to insert something after 10, then you have to find the element 10, or if I ask you to insert something after position 2, which would mean position 3, then you will do accordingly. So what do we do to add? We say create new node, which we have done before using malloc. So my new node is created. I put the values in 50 and null initially. Then I initialize temp to start and my position is 1. So when my temp is start, I am actually having the address of the first linked list node. So my position is 1 by default. So this is what I initialize position variable to. So while I'm using temp to next is temp is not equal to null. So I want to make sure that the position exists within the linked list. Okay. So while temp is not equal to null and position is not equal to 2. So my position is currently 1. So this condition is true. My temp is not null. So this condition is true. So you go inside the loop. Now temp is pointing to the next location. So I'll show you the figure again here. So this is my position 1. I'll go inside the loop, temp changes to temp to next, and position is also incremented. So position also changes to 2. So when you come back here, your temp is not null, but your position is 2. So one of the two conditions of AND is false, so you come out. When you come out, what is the value that was in temp? It was 2000. Okay. So let's get here. Now temp has 2000. So all you have to do is in 2000 to next, you have to store this address and you have to make this point here. But since if you do this first, you will lose this address. We'll do B first and then A. So here we go. This is my step B. In the next field of new, I'm putting the next field of temp. The next field of temp was 3000. So I'm updating my next field of new to 3000. So copy 3000 into new to next. And then in temp to next, I'm putting in new. So the pointer changes are pretty much the same that we did for addition. So if you notice, addition in a linked list at any intermediate position just involves 2 pointer changes. This is essentially what you will do after obviously looping and getting to the right position to do these 2 pointer changes. So this is the only thing that is required when you have to do insertions and deletions in a linked list. So if you compare this to your arrays, there if you have to insert something in between, then you have to shift all the elements from that position onwards till the end. And in case you don't have enough space, you will not be able to retain all the elements. If you're using dynamic memory allocations for arrays, then you'll have to reallocate memory. So there, if you've read through the advantages and disadvantages of arrays and linked lists, you'll see that this addition or deletion for linked list just involves 2 steps basically. These are 2 pointer changes and your linked list retains its structure and gets modified according to your requirements. So similarly, now when you have to delete, okay, so you can be asked again to delete a particular node with a particular value, or you might be asked to delete node at position 2, for example. Okay, so for example, again, let's say we have to delete 10. So if we have to delete 10, just a second. So if we have to delete 10, what is the pointer change that we are required to do? We are required to make this node 5 point to 15 instead of 10. Simple change, but then to do this, again, you have to delete 10. You got to be 1 before that node to make this pointer change, and then you can free this. So what we do, we say temp is equal to start. Location is 2. Let's say I am given the location 2 for deletion, not the value 10. It can be value 10 or location. So right now let's go with the location. So I've been asked to delete node number 2. So this is my variable, this is my loop variable, which I will use to loop and then get to the correct position to do this pointer change. So while temp is not equal to null, this is my condition. In case my linked list does not have location 2, let's say there was only one There was only one node in the linked list, so there's no position 2. This will help me come out. And ideally, after this loop, I should be checking whether I came out of the loop because of this condition or this condition. If it is this condition, that means I have reached the correct location and I can do my deletion procedure. But if I have come out because temp is null, that means this location does not exist. So I should check it, and then I should display a relevant message that this particular location is not present in the linked list. So maybe the linked list does not have those many number of elements as you want them, as you want to delete. So while temp is not equal to null and position is not equal to location -1, I have written location -1 because I want to be 1 before the node that I want to delete. So temp initially has 1000, your position is 1. So 1 is not equal to location -1, 2 minus 1. 1 is equal to 1. So I will never enter this loop in this particular case. I'll come out. So my temp has 1000. So 1000 to next is 2000. I am copying that to a variable, pointer variable called delete node. So why I'm doing this? Because I want to free this, which I'll free later on after I make the pointer change. Then temp to next, which is 1000 to next, which had 2000, which was the address of this node. That needs to be overwritten with 3000. So where do I have 3000 in my linked list? If I show you here in the original list, my 3000 is in, this is my temp to next is 2000, in 2000 to next is 3000. So what I'll do is 1000 to next is 2000, 2000 to next is 3000, and that is what I will copy at the place where I had 2000. Temp to next is 2000, 2000 to next is 3000, 3000 gets copied onto 2000, which means that this green link, now 3000 goes here. Okay, the next field of this is copied here, so that instead of this linking to this, now this will link to this. Okay, and then I will do free this node. Okay, and then like I mentioned, you might also want to add the check after this loop to see why you came out of the loop. Was it condition 1 or was it condition 2? If it is condition 2, then you're okay, you can proceed with your deletion. But if it was condition 1, you need to report back to the user that if you're trying to delete this particular location, I have hit the end of the linked list without finding this location. So you might want to try again with another value. Okay, or you might want to enter the value of the node. Okay, so in this one we did based on location. If you want to delete based on the element, so you'll have to modify this. How you will modify this, I have not written it yet, but what you will do is, this condition is okay. Instead of checking the position, what I want to do is to delete 10. I want to be 1 ahead in the sense I want to be before 10. So if this is my temp, I want to see, instead of checking the position, I will check if temp to next to element or data, whatever we have named it in our structure, temp to next to element, if that is equal to 10, then you come out, because then I need to keep this 1000 to make the change. So we can modify this condition here. Okay, we can modify this condition here and say if temp to next to data, if that is what we have named in our original structure, is equal to 10, then this is when you will have to come out and do the deletion. And this, again, you can do this only if temp to next is not equal to null. Okay, so you have to make sure that you do not hit a null pointer, because if this somehow turns out to be null, then you will be actually writing null to data. So it's better that we move this particular loop check inside the loop, so that, because when temp is not equal to null, then you can come inside and safely write this. If temp is equal to null, in any case you would exit the loop. But whenever you use something like this, you should always make sure whatever is here is never equal to null, because that will give you a error condition. Okay, so this was your addition and deletion at intermediate nodes. So what we have done, we have, let me go back to the earlier nodes. Okay, so we have completed add in the beginning, add at the end, add at any other intermediate location by position, location number, or you can be asked to add something after the node that has value x or y, whatever. Delete in the beginning, delete at the end, delete at any other intermediate location by position, location number, or by value of the node. We have already written the loop to traverse. The loop temp is equal to next. This can be, if you check the link that I have provided, if you see the print, this is how you will print. You will add another line within this loop which says print temp to data. So you will be able to print. Count the number of elements. Again, you will use this, have a counter equal to 1, and then do count plus plus and print that count in the end. I'll come to that later. And then search. Again, search would be the same loop modified with a if condition which checks the value of the data. Okay, so we'll cover that in the next one. For now, I think we are done with the basic functionality of the linked list. Please go through the link that I have provided in the lecture outlines. I think most of the coding and functions are given there. You can, these are, I have not written the exact function or code, but I have given you the main important working of each of these functionality, and we have to club this together to form a full linked list program. The link that I have provided, I think it has all of it. I'll go through it and I'll provide you relevant, more detailed information about what to go through that in that particular page, and then we'll try to cover more topics from here on after I get feedback from you for these lectures. Okay, thank you.